Okay, hello student. I think in last lecture we have covered this all things. What is simple lifting machine, load, efforts, mechanical advantage, velocity ratio, efficiency of machine, reversibility and non-reversibility that we need to understand. Again, self-locking machine, and before that I think we move towards the ideal, right? Okay, just we need to understand today some basic concept that I will tell you. Don't worry about it. Okay, now see here. So in today's session we are going to see what is ideal efforts. Okay, which is denoted by pi, suffix la I, right? Second one is the ideal load. Don't take the so much load. That's ideal load, that is Wi. Okay, then efforts lost in friction. Similarly, load lost in friction. Okay, these are the things we need to understand today, okay, in this session. Now see here, what is the ideal efforts? Okay, so whenever there is an ideal word, we need to remember that it is 100% efficiency for the machine. Okay, then when we see the ideal efforts, means the efforts which lifts the load at 100% efficiency of the machine. Okay, means this is the ideal efforts which lifts the load with 100% efficiency of machine. Okay, remember whenever there is an ideal word, use a, we have to remember for the machine that is 100% efficiency. Okay, and second thing, what is the ideal load? Okay, okay, this is the load which can be lifted by an efforts with 100% efficiency. Okay, clear? This is the efforts which can lift the load, okay, with 100% efficiency, and this is the load, okay, which can be lifted by the efforts with again 100% efficiency. Then how to find out the formula for these two one? For these two, we need to use the one characteristic of ideal machine, that is mechanical advantage is equal to the velocity ratio. Okay, we know that the mechanical advantage is load to be lifted divided by efforts to apply, the efforts to which is applied to lift the load. Okay, velocity equal to the velocity ratio. Now to find out the ideal efforts, okay, for this P, use the suffix pi. Obviously here is I, then you get the ideal efforts. Now take this pi to this side. Okay, then obviously this vr means velocity ratio to this side, and you will get pi is equal to the w, means load to be lifted divided by velocity ratio, which is the formula of ideal efforts. Okay, similarly to find the ideal load, again we have to use this characteristic, that is mechanical advantage is equal to the velocity. What is the mechanical advantage? Load to be lifted divided by efforts to apply to lift the load is equal to the velocity ratio. I want to find out the ideal load, means W suffix I, then give suffix I over here. And you will get obviously W suffix I, that is ideal load, is equal to P into velocity ratio. This is the formula for ideal load. Okay. Now next thing is we need to find out efforts lost in a friction. Okay, and load lost in friction. Now for that, one thing we need to remember, that is actual and ideal. What is the relation between actual and ideal efforts, and what is the relation between ideal load and the actual load? Okay, now see here, due to the frictional losses, we need to apply the more efforts than the required. Okay, that's why actual efforts are greater than the ideal efforts. बरोबर, मशीन मध्ये फ्रिक्शन असल्यामुळे आपण काय करतो, तर जेवढे एफर्ट्स गरजेचे असतात पर्टिक्युलर लोड लिफ्ट करण्यासाठी, त्याच्यापेक्षा जास्त एफर्ट्स आपल्याला द्यावे लागतात, कारण त्या मशीन मध्ये फ्रिक्शनल लॉसेस असतात म्हणून. ओके, क्लिअर. हेच गोष्ट जर आपण लोडच्या बाबतीत बघितली तर हे लक्षात आलं पाहिजे की 100% इफिशियन्सीने आपण जेवढं, म्हणजे 100% इफिशियन्सीने जेवढं लोड लिफ्ट करू शकतो त्याच्यापेक्षा आपण ऑब्विसली इफिशियन्सी मशीनची फ्रिक्शन लॉसेसमुळे कमी असते, त्याच्यामुळे आपण लोड जो लिफ्ट करतो तो कमीच लिफ्ट करू शकतो. याचाच अर्थ काय, आयडियल लोड हा ग्रेटर दॅन ऍक्च्युअल लोड असतो, हे लक्षात ठेवा. आता हे ऍक्च्युअल एफर्ट्स हे ग्रेटर दॅन आयडियल असतात, मात्र आयडियल लोड is greater than the actual load. Okay, by using these two things, okay, we are going to find out the efforts lost in a friction. Now see here, efforts lost in a friction I will indicate by P suffix F, that is PF. Okay, then which is the difference between the actual efforts and the ideal efforts. As actual efforts is more, take actual efforts first, minus P. Okay, now put the formula of ideal efforts, that is we have found over here, W divided by velocity ratio. This is your obviously formula of what, efforts lost in friction. Similarly, we want to find the load lost in a friction, W suffix F is equal to here. So again it is the difference between ideal load and the actual load. Now ideal load is greater, that's why take the ideal load first minus actual load. Okay, then ideal is P into velocity ratio, we have found over here, clear, P into velocity ratio minus W, that is actual load. This is the formula for load lost in friction. Clear? So all of you remember that formula of ideal efforts, ideal load efforts lost in a friction and the load lost in a friction. Very clear. Okay, based on all these concepts we need to solve the numericals. Okay, and one more thing, that is law of motion, then reversible machine, non-reversible machine, we need to understand, that we will take into the next session. Okay, thank you very much all of you.